it just gave me the information that the meeting is being recorded. So we can also establish a virtual classroom, just like you see in this image. It can be a VR classroom or PC classroom with Realip Academy software. So there are multiple flexible ways to use our platform. You can see a couple examples here. At the left part, this is a medical university that are using one of our laboratories in their PC laboratory, actually. So the students can access to the platform through the PC devices in school. And at the right part, you can see there's schools that want to have a VR classroom or a VR corner with all the setup. So they can also purchase the Realip Academy workstation. And with distance learning, oh, Ira raised a hand. You can ask along, please.
Yeah, I'm a little confused as to why there needs to be a lot of like desktop monitor computers. Are students working in that space that we were just looking at, or are they like remote logging into those computers?
No, this is actually for institutions. There are two ways to use the system. So they can purchase it for institutional usage, and they can use it from the school in a physical PC laboratory. So for example, in between other laboratories, students can use Realip Academy laboratories as well while they're in the school, or this, the school can actually purchase for each student. So the students can have access no matter where they are, from home, from school, with their licenses, as long as they have the internet connection. And that's all. So there are multiple ways for institutions as well. That's an example on how actually things are going right now with distance learning. And we truly believe that this will be an ongoing thing through the hybrid education as well. So right now, mostly the teachers are sharing their screen while performing the experiment after they finish one subject. And then there are multiple ways to use it also. They can give it as homework, as weekend study. It can be a project as well. The system is working with Java right now, so you don't have to download anything to your computer. You just use your username and password that you get from the sign-up process, and then you can log in. Currently, we have two versions, as I mentioned. For VR version, you need VR goggles and touch controllers. And for PC version, the only thing you need is your computer and an internet connection. The content is the same. So you will be receiving same information, same experimental environment from each version. But of course, with VR version, the users can feel more like inside of the environment, and the experience is different, of course. Currently, we have 10 laboratories from biology to medical biochemistry. And as you can see, we have multiple physics laboratories, such as electric mechanics, optics and waves, thermodynamics. And we recently developed Realip Academy Junior, which is for elementary and middle school. When I get into one lab, let's say I'm inside of the mechanics laboratory. If I click one experiment, then I will be seeing a brief information about that experiment, and also two buttons. So if I click to manual, I will be having access to experiment information form in multiple languages, but all of our experiments are available in English. So I can check the experiment information form just like in a physical laboratory, the lab manual. I can get information about the theory, the tools and materials I will be using, and the experimental procedure, as well as the tables and graphs in blank versions. So I can fill them, and I can use this PDF file as a lab report as well. And I can start with the start. This is our current experiment list. You can find it in our website as well. There are experiments for high schools and universities. And we keep developing experiments each month. So when an institution purchases the laboratories, they will be getting free access to those updates and newly added experiments during 1-year process. And this is the junior experiments. We have additional introduction activity, well, relating to the age group. And these experiments also aim to encourage younger students for science. In platform, you can also find 3 other sections other than the laboratories. My data section is quite important because this is where you receive your data. So you can find it, you can find the tables or the graphs you received from the experiment here. And VRLab Academy Live contains the tutorial videos that recorded by our science department. It's inside of the platform and everybody can reach it. So the users can check if they have any questions about the procedure of the experiment. I'd like to show some screenshots from the lab environment. So you can see our main aim is to design as realistic as possible. And on top of the lab desk, you can see a tablet which says theory and experiment. So if I click to the part that says theory, I can find the experiment information form again. I can check the theory and the procedure as much as I want during the experiment. Also for other laboratories, you can receive graphics and tables. You can actually change the parameters of the experiment so you can gather data that is different each time. And as you can see, we have modern physics laboratory as well. These material and these experiment sets are highly expensive and really hard to reach for both teachers and students. So with this system, the students can actually reach those material one by one, and they can receive their own data because they will have their own license for the platform. Also for thermodynamics laboratory, you can perform an experiment in value ranges that you cannot actually perform in physical laboratory, or for chemistry, you don't need any consumables. This can also be for example, a side platform besides your own physical laboratory, because you can actually go through the lecture and then perform one experiment and then continue with your lecture with the system as well. And for biology laboratories, it makes it possible to observe stuff that you cannot actually observe in real life. Popular science laboratory for students that want to check general science knowledge. And we have more than 100 sensors inside of the lab. Ira, please go on.
Yeah, I'm wondering, all of these instruments that we're seeing in these screenshots, do they, is there some way of measuring uncertainty? Is there some sort of implicit uncertainty in the simulation that we get out in the data?
Yes,
maybe I can
right now, please,
give some information about this. I'm sorry, I just interrupted you. But we are just working on how to incorporate uncertainties and errors and uncertainty analysis. So when we complete this upgrade, we will be able to also provide tools for uncertainty analysis. But for the time being, we are just basically performing the measurements. But after Emine Hanım finishes her presentation, we will give some more detailed information about how the system works. So without our upgrade is before our upgrade is completed, I can recommend you some ways to incorporate the uncertainties if you want to use our system in class.
Thank you.
And as I know, also Dr. Alpa can correct me, so the students can perform the experiment with different measurements, and they can compare the outcomes, and as well as they can take it the experimental outcome, and they can do the theoretical calculation as well beside of it. So in the system, we have more than 100 sensors. You can think it as a way to log the data. So the students can decide whether they need a sensor for that experiment, and they can grab it from the sensor station. They can implement it to the experiment. Currently, we have 3 lab assistants. They are Bella, Rita, and Amy. And they give theoretical information to the users, and they can warn if they need it, or they can, for example, tell the user if there are any prerequisite stuff, like you need to change your pipette before you do that, blah, blah. So they can give a warning, and they walk students through the experiments as well. For some customer impacts, I can talk about some advantages. So the teachers, as I said, can give homework through VR Lab Academy, because each student's data will be unique. And this data relies on real scientific formulas, since we have a science department, and they are creating the content and the scenario of the experiment. And educators can act more flexible. As I mentioned, they can just interrupt the class, the lecture, and they can perform the experiment and then continue to their lecture as well. All of our experiments are curriculum based, so we do the mapping on that correspondency to your curriculum. So the academicians can also see that which weeks they need to perform which experiments. And I will mention about the academic collaboration in the next slide. That's a research from 2019 that's held in Saga University, Japan. So they took EEG data from students, and this EEG data shows that students in virtual reality classes are way more concentrated, and this concentration actually maintains 6 times longer than the other types of education. We also have LMS integration with our system. So if your school is using an LMS system, a learning management system, we can integrate VR Lab Academy into that system. So it becomes single sign-on. The users don't have to put their username and password each time. And VR Lab Academy becomes a side resource here in your LMS system. And also with this new improvement that we will be finalizing in September, and they will be ready for the new semester, there is this teacher dashboard. So when we integrate to LMS, the academicians can see more data about the students, such as their data that they received from the experiment can be CSV files, Word files, of course, depending on the nature of the experiment. And the teacher can also download this to their computer for their assessment and evaluation process. And also, as an instructor, they can see the process of the student for each experiment and for each laboratory. So as academic collaboration opportunity, this is something we do for further education experiments, or if we don't have an experiment in our portfolio that is being studied in an institution by academicians, we can develop this experiment or this laboratories in a collaboration. So the only thing we require from these academicians is that theoretical explanation of the experiment, scenario, or some references for the materials that we need to use. And then we set several meetings, and then our design and software team develops the experiment. Then we launch it from our website. That's an example from a spectrophotometry experiment that we developed with ETH University Medical School with 3 professors. Then we launched it. And globally, we have partnered up with Intel and Lenovo. This is from London, 2020 Bat Fair London. So they were using our software and their hardware to this fair. Another very important project for us is Artificial Intelligence Science League. This Science League will be between Yarlap Academy user institutions. So these institutions will gather student groups, and we will be sending artificial intelligence problems through our platform. And this will happen 3 times in this year, and they will be sending their solution algorithms to us. And in the finals, the academic committee will be deciding the awards, and this will take place in London in 2022. I hope if the COVID lets us. So thank you for listening to this presentation. If you have any further questions, we can answer it. You can also find us in the virtual booth at the right below part. There is this Yarlap Academy virtual booth, and we will be answering questions. Also in underline, you can find us in the expo part, written as Yarlap Academy. We can have a Q&A, and I think you have dropped your emails, and I will be reaching to you. So right now I am passing this to Dr. Olpak, and he will be giving an explanation about our platform, how do we use it, and I hope he will be giving some information about how are we moving inside of the laboratory, and also he will demonstrate an experiment from physics. So thank you, everyone.
Hi again to everyone. My name is Mehmet Ali Olpak. I'm an assistant professor at University of Turkish Aeronautical Association in Ankara, Turkey. I'll try to briefly introduce the system to you, and Gürcan Bey will help me on the demonstration of the system. So I'll also try to address your questions as well while discussing, but if you like, you can also ask while the presentation is going on. So here you see our portal where you can access the experiments. That's where you see when you sign up to the system. And this is one of the experiment groups under the physics experiments, so the electricity and magnetism group. And here, as you see, there are other groups as well. The modern physics laboratory or thermodynamics laboratory, and we are trying to increase the number of experiments under each group. So there are also groups of biology and chemistry laboratories, and more specialized like biomedical, medical biochemistry laboratory and other more specialized laboratories are also on the way. So we can, for example, well, we will discuss one of the examples on this system. Emine Hanım also talked about some basic features of the system. So one important feature is the My Data section. If you perform an experiment and save your data, record your data, you can access the data from that feature, and this makes it possible to work on the data further after performing the experiment. For example, Ira asked about uncertainties. As I explained, the uncertainties are not incorporated for the time being. They are waiting for the upgrade. But when you perform an experiment and take some specific set of data, you can introduce your students some uncertainty by assumption. For example, if you are making use of a ruler to measure distances, you can introduce an uncertainty of 1 millimeter, for example, and you can ask the student to analyze his or her data using that amount of uncertainty for each data point. That's one specific example on how to incorporate uncertainties manually, let me say. We also have some videos, example videos, which demonstrate the use of our system. Those videos are also prepared. I mean, the experiments are performed by our staff or by teachers from the fields, corresponding fields. So there's a kind of a twofold way of using this system. You can assign the experiments to the students and they can perform the experiment, take data, make the analysis and so on. Or you can use it as an instructional material in your class. The teacher can perform the experiment and explain the topic which is related to the experiment as an instructional material. I mean, using the system as instructional material. You can also access the manuals, lab manuals on the system as well. They are provided in various languages. Well, English is present. I mean, English version is present for all experiments, but we are increasing the number of language options as well. So in the lab manual, that's a standard lab manual, by the way. You have the aims of the experiment, so they are in a sense mapped onto the learning outcomes. You have the theory section, and you can find, the student can find relevant theoretical information about the experiment. We have tools and materials. We have the experimental procedure, and the experimental procedure explains every step to the student on how to perform the experiment. And when the student does not follow the procedure correctly, he or she can make mistakes throughout. So our system does not simulate all of the physical properties of the devices. Rather than simulating the devices, we are trying to simulate the experiment, the whole process itself. So for this reason, not all of the real life mistakes are possible, of course, on the system, but it is very likely that the student gets a weird result by confusing some of the steps and doing the experiment in a partially wrong way. So this is one of the most important issues in teaching, as we all know. The students should be able to make mistakes to learn how to correct them. We have the tables and plots and some calculations related to the experiments as well. So this laboratory manual is, for example, one of the Airtable experiments. So it's a universal system, as you know, in physics laboratories. There are various experiments that you can perform: straight line motion with constant velocity, with constant acceleration, or you can study conservation of momentum by studying elastic collisions. So this is how basically the lab manual looks like. There are also these conclusions and discussion section in the lab manual. It allows the teacher to elaborate more on the content of the experiment. The teacher can add extra questions or request extra calculations related to the experiment. So there's this kind of flexibility in the system as well. So if you like, we can show an example from this Airtable system. So the system being web-based is also another nice feature that makes it useful. I mean, as assignment experiments or as an in-class instructional material. So you see the language options at the beginning of the experiment. You choose your option and then you enter into the system. Amy gives some information on the experiment as you start the experiment. The laboratory assistant gives some theoretical information and maybe some tips about how to perform the experiment. The student can listen to the laboratory assistant first to remember and collect all the relevant information that is needed to perform the experiment. There is also a VRLab tablet on the bench, so we can have a look at that. So that's the VRLab tablet, and as you see, there's a theory section and an experiment section. Under the theory section, we have the laboratory manual, one more time. So the student can go back to the theory section to remember anything necessary, basically. And the other section, the experiment section, is related to the data. And when you perform the experiment and begin to record data points, they will appear on the tables which are present under the experiment section. So in this one, Airtable experiment, we have basically 3 experiments. We can perform straight line motion with constant velocity, straight line motion with constant acceleration, and conservation of linear momentum by studying the elastic collision of 2 pucks on an Airtable. So maybe we can see one of them. For example, straight line motion or conservation of momentum, any of them. So the student takes the puck. In order to grab the puck, you need to use the clicks of the mouse. And in order to navigate in the system, or in order, if you want to grab any object, you just use the left click. And in order to leave it down, you need to use the right click. So we take the puck and we leave it for, we launch it for straight line motion, and we take the position time data, and it is directly reflected on the table under the experiment section. We can draw the graph of this data, for example. So as you see, uncertainties are not for the time being incorporated, but they will, we are preparing an upgrade after which there will be random uncertainties in these data points. So we are just preparing it. So the plot appears on the whiteboard. And also, if you like, you can, for example, ask the student to prepare a separate graph by making use of the data as well, or study on the graph as well. So in this system, we can change certain properties. For example, we have a spark timer whose frequency is adjusted. And by adjusting the frequency, you basically arrange the time intervals between 2 successive data points on the Airtable. So that's the universal setup, as you all know. I think there's no need to talk more about this. So the launch force is basically the initial push that you give to the puck, and you can arrange it as well. So you see there are 2 more buttons. There's a reset experiment button, and you push on that button, all experiment is reset, basically. And for the other one is related to the conservation of momentum experiment, the start collision button. And so as you see, the table is reset as well when we push the reset button. So this is the acceleration experiment. And on the other one, you can perform the free fall experiment, basically, on an inclined Airtable. You can adjust the slope of the Airtable, the inclination angle. By the way, as you see, the system tells you to put the object into some place, a specific place, so that you can perform the experiment. It appears as an area which is in the shape of the puck here, for example. Okay, so it leads you for the experiment as well. And you have your data now, and you can draw the graph of this data. So this is position versus time squared. So you get a linear graph with 0 initial conditions. And again, you can introduce, for example, an uncertainty in time measurements here in this one. For example, in many systems that in many applications of Airtables, those spark timers have a percentage error of like 5%. You can introduce this to the student and ask the student to analyze the data by assuming the existence of such an uncertainty. Well, also the teacher can prepare mock data as well. Ira?
Yeah, I didn't notice did you have the chance to choose the way that you wanted to represent the data, or was it automatically switched to an x by t squared?
So in this one, it is automatic.
Okay, interesting.
In this one, it is automatic. But as long as you have the data, you can perform further analysis. For example, you can request the student to plot x versus t graph and try to fit a parabola for this one. I mean, it depends on how the teacher wishes to use the system. So the crucial point of our system is that it is visual, it is realistic, and it provides a laboratory experience, really. So this is the strong part, and it works with real formulas. So it's also another strong property. I mean, we began with fixed data sets at first, and we upgraded them to generic data sets. So we give the system the formula, and the system generates the data, basically. And that's how we will be able to incorporate uncertainties as well later on. So these are the strong parts of our system. Of course, as I said, we are simulating the whole experiment process. That's why the physical details of, I mean, some of the physical details of the devices are omitted depending on the experiment. Well, on one side, that can be a disadvantage because some of the possible errors are not present in the system. While on the other hand, it can be an advantage because the student can focus on the experiment rather than struggling with the device itself. So that's our preference, actually. I mean, that's our philosophy behind this system. So the whole experiment process is what is important to us. And we are trying to simulate the process itself, I can say. Well, I don't know if there's anything I have missed or forgotten. There are also other devices that, I mean, if it is possible to use in the system, other devices are also present in the laboratory. The student can grab the object and put it on the bench and use later. And there are exit buttons. If the student is done with the experiment, he or she can exit from the laboratory by clicking on the exit button. So these are some basic features of our system. We strongly recommend you to have a look at them during the 3-day demo access. I guess everyone gave their email addresses. That's nice. Well, we are proud to demonstrate our system. If you have any further questions, I'd be glad to answer them. Thank you.
Thank you, Dr. Alpert. I think there only Glenda and Dylan haven't shared their email. So if you can share your email with us, we will be providing a demo access for our platform. So you can see how to perform the experiments. I will inform you when the experiment is activated for you. And we will be in the virtual booth during the presentation sessions for 4 days until Wednesday. So you can visit us in the virtual booth. Also in underline interface, you can find us in the expo part and join a live Q&A with us. Also, you can request a demo meeting, which we can attend with our science department, and they can give you another demonstration and answer your questions if there are any. So Scott asks that does this lab allow students to create original experiments from available virtual equipment? Right now, we don't have it as an open source, but this is in our pipeline for the next year. So we would like to give some equipment to the student, both for chemistry, physics, and biology laboratories separately, so they can create their own experiments, but that's in our planning. Did I say it correct, Dr. Philippa, can you?
Well, I have nothing to add.
Okay, elaborate on that. Okay.
Well,
I think
maybe
this was clarifying, Scott.
Maybe we can share a couple of ideas about this. So that's also related to the last question that Ira has asked. You can basically design this kind of a system in two ways. You can concentrate on the experiment process as we do, or you can concentrate on creating digital twins of laboratory devices. So that's another approach, actually. For the time being, we are more on the educational side. That's why we are concentrating on the experiment process. That's why we deliberately we are not, creating digital twins of laboratory equipment. But as Emine Hanım just said, this is in our schedule. So we also want to make use of the second approach as well. For example, you can think of a system, I don't know, like the simulation of an oscillator, for example. Okay, the student can work on that digital device or the digital twin of that device and design his or her own experiments. That's, in a sense, a second step for us.
Thank you. Is there anyone else that have questions? We haven't heard from Dylan. Do you have any questions, Dylan?
Sorry, no, I apologize. I came late, so.
Yeah.
It's fine. There are many presentations.
I have a question. In connection to the graph that we have had in the presentation with the t-square, there might be a connection in the manual maybe, so that students know the reason why they have the x versus t-square graph. Would that be correct, Mehmet Hocam?
Well, that's a nice idea, actually. If I don't misunderstand you, you mean by clicking on some link, the student will be addressed to the relevant section in the lab manual.
No, I think
no, actually in the lab manual itself, it explains why students plot x versus t squared. That's why that graph is generated. And the manual itself somehow leads you to generate those graphs, but teachers always have the option not to choose the manual itself. As Mehmet Hocam explained, they can also plot x versus t graph in an Excel document. I think those data will also be generated in a CSV format, isn't that?
Yes.
Right.
So you can also have options to generate other graphs.
Right.
Of course.
For example, the teacher can perform the experiment as instruction in class and take data, and after that introduce some uncertainties and create a mock data over it, and perform the analysis of that mock data to demonstrate step by step how the measurement and analysis process proceeds. That's an option, for example. For example, you can shift the origin of your time coordinate. Okay, you can assume that the experiment starts at t equals to 5 seconds and explain to the student how the plot looks like under these conditions, x versus t or x versus t squared. As long as you have some Excel table, that's possible, and that's the nice thing.
Right. There was another question about the short circuit, I think, in the chat dialog box. We can also address that question in terms of mistakes. I was part of this group writing an experiment on Van de Graaff generator, for instance, and students had to connect the wires to get the system working, and myself made a lot of mistakes to get it right in the first place, and the system doesn't work if you get the connection incorrectly. But I don't have the experience to try out an electrical circuit. If a short circuit happens, does a fire comes out, or that would be an extension maybe in the future, but it doesn't happen right now. But maybe Mehmet Hocam can answer that question. Is there a short circuit if students connect the wires incorrectly? Does it show the current as 0, or?
Yeah, it's similar to your experience, actually. The system does not work under these conditions.
Doesn't work. Okay.
But I agree, it would be nice if some burst of flames appear in the system and the student sees that I'm doing something wrong. So
Right.
that would be nice, but as you said, that's maybe an upgrade.
We have similar stuff in chemistry laboratory mainly. Actually, it's like animation boosted for some wrongly gone solutions, and in biology as well. But we can very well add to physics laboratory if there are any animations needed.
I have another question. Even though I am part of this group, I would like to ask that how many years did it take you to generate all these experiments?
Well,
Can you
I'm
ask
here
again?
for 1 year, so I shouldn't answer this question, I think.
Can you ask again, please?
For how many years did it take for you to generate all these experiments?
Like 2 years.
So in 2 years' time, this much of progress being made, I can imagine how much more can be done in 2 more years' time, I guess. In terms
for
of,
example, this is how we developed Junior. There were like a huge amount of demand actually for elementary and middle schools to have access to virtual laboratories as well. And since we have the know-how and R&D department and software and design departments in-house, so we were able to also develop the junior section in like 6 months, we can say we have started.
You must have a big team, I guess, to be able to create so many of these experiments in such a short amount of time.
Yes, we have 3 different offices in Europe, and since we have all the teams in-house, we have this really good relation and connection between science team to software team to design team. And that's how we are able to actually develop experiments with academic collaboration as well, because now that we have a science department, they can actually have conversations with academicians. So that's, I think that's easier for us than another company to do that.
That's a huge strength to be able to have the software engineers, I think, in place in-house. I think there are more questions in the chat dialog box. Would you like to answer them, Emine Hocam? Are students able to output their results to
I am answering right now, but I think I have sent it to Dylan wrongly.
Scott.
I am answering them from chat for everyone.
I think the system can also be integrated in LMS as well, so any learning management system, so that students can submit their work as a lab report.
Yes, we have LMS system. And with the new dashboard, we will have several more features. I think maybe Dr. Olpak can mention about that, about the assessment process. So with teacher dashboard as well.
So the options to submit the lab manual as I mean that's point is clear, I guess, for the time for now. Using the LMS integration, the teacher will be able to access more data on the performance, on the process that the student experiences in the system, and that can also be related to the assessment of student performance. So, for example, you will be able to see how long the student is present in the system, and also you can track how much of the experiment is performed by the student, and the access to the recorded data and other assessment items would be also useful from the place of the teacher, I mean. So they will be in one place when the LMS integration is also performed. And so, I mean, you can compare this, for example, with other LMS systems like Moodle, which provides similar opportunities. Of course, Moodle has nothing to do with experiments, but in terms of assessment, I mean. And also the kind of flexibility about the system that we have talked about lets the teacher, by making use of the LMS system, lets the teacher to build his or her own extra activities on the experiments as well, like pre-quizzes or exit quizzes. For example, in my experience as a research assistant previously, in previous years in Middle East Technical University, we used to give 2 quizzes to the students before the experiment and after the experiment. And that's also another option for the teachers. We are also, by the way, incorporating these options in our lab manuals as well, partially. But as I said, you can add whatever you want on this content.
Scott has a question. I'm not sure if we addressed that question. Does this lab allow students to create original experiments from available virtual equipment?
Yes, I think we have answered that, that it's in our pipeline for the next year, create such laboratory and or experiment, and he says yes. And I think I have answered the other question of, are students able to output their results to hand in as a lab report? That's what we mentioned as lab manuals. So they are in PDF format and they have the blank versions of tables and graphs. They can also use this PDF as a lab report. Right now, there are many schools that are using Realab Academy manuals as their lab reports. And they can also implement their data to the school's own lab report as well. Are there any other questions that you would like to ask? I think all is answered for Scott as well.
All clear.
Yeah.
Okay, thank you everyone. So you can find us in virtual booth and in underline Explore Realab Academy. And Scott says he doesn't have any more questions. Also, thank you, Scott. And we will be seeing you in the next days.